Anyway. All right. We are finishing up this unit today. We talked about arithmetic sequences and series. You guys did your geometric sequences last time. Looks like you're doing pretty well. So what we are going to finish up with are geometric series. Okay. So our main goal today will be to evaluate geometric series. If you don't have your calculators out and handy, which you probably do, get them out because you definitely need them for today. We do have one more formula to look at. Like I've said all along, you do not have to memorize these formulas. They will be given to you, but it does not tell you which is which. So you do have to at least be able to recognize them and know when. All right. All right. So in general, a geometric series is an indicated sum. Remember, series equals the word sum of the terms of a geometric sequence. Your sequence is your list of numbers. Your series is your sum of a certain amount of those. All right, we have one more formula. And this formula will find the sum of any number of terms of a geometric series. S sub n equals the first term times the quantity, 1 minus r to the n over 1 minus r. These variables mean the same thing as they've meant in other formulas. That t sub 1 is still our first term. The r is our common ratio. Our n is the number of terms that we are summing. Okay. Let's go ahead and look at the first example. It says, given the series listed, approximate s sub 8 to the nearest tenth. Now, here's the deal with geometric series. Notice in this one, the next term adds basically another decimal point. So if you think about like the 80th term, how many places will you have after the decimal? Like a lot more, yeah. So when we add up all those numbers that have all those decimals, it's going to be a really big decimal. That's why we approximate to the 10th. Okay, just wanted you to understand that. So let's start with our formula. Even though we just wrote it, let's write it again. And let's plug in what we know. So I know I'm finding s sub 8. I know my first term is the 6. So 1 minus, what's my value of r? How did you get that?
I just put the difference between 6 and negative 14.4.
You did what?
Like, I did 14.4 divided by 6.
Exactly. Guys, the common ratio is the ratio of the, like, in this case, term 2 over term 1 or term 3 over term 2. Okay? So you can always find that common ratio by dividing. Alyssa, what did you say it was?
Negative 2.4.
Negative 2.4. So now that we have that common ratio, we can plug it in. Be really careful here, though, because this is 1 minus negative 2.4. So I typically put that in parentheses. And then the value of n is 8. all over 1 minus negative 2.4. So there's a lot of places to make a little mistake. So be really, really careful when you're using this formula. There's a lot of places to make a silly mistake. All right, grab your calculators. We're going to do this together first because it, again, it can be really easy to make a mistake with your calculator here. If you, this is going to sound mean, but if you do it the way I tell you, you'll be all right. So listen, okay? Do this with me on your calculators. 1 minus parenthesis negative 2.4 to the 8th, close your parenthesis. Hit enter. Keep that on your screen. Divided by 3.4. Why 3.4? Yeah, 1 minus negative 2.4 is really 3.4. Hit enter. And then at the very, very last step, then multiply it by 6.
Wait, where did you get the 3.4 from?
What you should be getting, hopefully I told you the right thing, is negative 1,940.7.
I didn't get negative.
I have 44.6.
Given the series listed, find S sub 16 to the nearest tenth. So again, let's start with our formula. And I'm looking for S sub 16 this time. First term listed is the 400. Times the quantity, 1 minus, have we found the common ratio?
0.75.
Okay, good. So minus 0.75 to the 16th over 1 minus 0.75. So try this on your calculator without my help. I will tell you what you should be getting. That way you can make sure you're entering it correctly. We should be getting 1,584.0 if you round to the 10th. The next couple series that you see are written in summation notation, which we haven't worked with in a while. What you guys have to understand from the summation notation is a couple different things. The number listed first is your first term. The number listed with the k minus 1 or n minus 1 or whatever it is your common ratio. So even though this series is written in summation notation, you have from it the information you need as long as you understand what to look for. So let's think about why these are what they are, because I could certainly just tell you and move on, but let's have a little bit of an understanding why. Think about plugging in, and by the way, I'm missing k equals 1 on the bottom. I'm not sure why that's not there, but it's not. All right, let's think about why these are what they are. If we plug 1 in for k, if you plug 1 in for k, 1 minus 1 is, so negative 2 to the 0 is 1. Times 1.5 is 1.5. So when you plug in 1, you get that number. Okay? If you think about plugging in 2, so we would have 2 minus 1 is 1. So negative 2 to the first is negative 2 times the 1.5. You end up multiplying each number by that negative 2. Okay, so that's why those numbers are what they are. Okay? With that being said, from the summation notation, you can still use that same sum formula that we have been using.
Wait, does the 5 tell you? Okay.
The 5 tells you what?
Like how many you're adding?
Exactly. That 5 is your value of n, exactly. So in this case, we're finding s sub 5. First term is 1.5. The common ratio is negative 2. Watch when you have a negative common ratio, because that tends to make people make mistakes. Okay. Take a second with your calculator. When all is said and done, we should have 16.5. So if you are struggling with your calculators, let me know. Okay, do that. For 4, Sebastian stood up. So our value of n is 7, so s sub 7. What's my first term? You guys have to understand how to look at these summations. 4. Times 1 minus, what's the common ratio?
Negative 5.
Negative 5 to the 7th, all over 1 minus negative 5. Take a minute, plug that in your calculator, make sure we know how to enter this. The hardest part about this lesson is using your calculator.
Yeah,
It really is. We should be getting 52,084. Alrighty, if you invest $2,000 every year for the next 10 years, so every year you are also adding $2,000 more to it, okay? You earn 8% annual interest. How much do you have at the end of the 10th year? All right, so first of all, we need T sub 1. What do you think it is?
2,000.
It's not 2,000. Guys, listen, T sub 0 is the 2,000. That's what you put in at the very beginning of the time. After the first year, you get the interest.
Take away
No, you're getting interest.
2,000. There's a 2,106.
20. How is it that much?
It is 2,160. So you're I'm sorry, I really did not hear you.
Oh, I did say, I was like, wait, I don't know how much.
If we multiply it by 1.08, that adds in the interest after the first year. That's the. But in any case, your first term is 2160. That means that is the amount you have at the end of year 1. Is that clear? Okay.
Yes.
What is the rate? What is, not the rate, but the common ratio, I should say, which is essentially the rate. What? 1.08. What's the value of n? 10. Good. From here, you have everything that you need to use our sum formula. So we're finding S sub 10. We discussed that our first term is 2160 times 1 minus 1.08 to the 10th over 1 minus 1.08. Try that in your calculators.
We don't have to do the million parentheses.
I would still use some, yeah. Make sure that you're getting $31,290.27. All right, how about 97 cents? Do you like that better?
Yes.
Yeah.
Why is mine rounding up before I get to the decimal?
I don't know.
It's not square.